All right. Good morning, good evening, good afternoon, everybody. And thank you for joining Going Meta, Season 3, Episode 3. I cannot believe this is the last one for 2025. I'm very happy to have you here with me again, Jesus. Welcome to Going Meta.
Hello, Alex. I'm in one of these embarrassing moments where I have you in one of my multiple open tabs, but I can't find you. So I'm going to talk to you.
That's all right.
The good
I can
news,
hear you.
it will be.
I can see you. It's like
I
this
was trying
this
to.
joke. Too many browser windows, and where's the music coming from? Um, so
Good. No,
that's
no, but yeah, great. I mean, it's unbelievable that we come to the end of I don't know if it's the third, the fourth year, but definitely the end of 25, and with a really interesting topic. Well, actually, a topic that we've been talking about for many times, but a bit of a different angle that we're having today. So yeah, looking forward to it.
Yeah, exactly. So you already mentioned it. The topic today, just for me to read it out, is and we settled on this title.
Yeah.
For it, Ontologies LLMs Property Graphs. Do we really have a Jaguar problem?
Yeah, no, it's a very
Yeah.
very particular title, and those of you who know what it's about. It's funny because well, let's give the context and let's get things started. But I was literally chatting with the author of the post or the work that we're going to be kind of unpicking a little bit today. But yeah, let's get started because I have to show to give the context and
I think
what do we mean by settle. But I don't know. I don't want to jump into that. If you have some announcements to give, anything that, or maybe we'll leave it for the end. Or
we can definitely leave it for the end. And as usual, we have a couple more things going or taking place before the end of the year next week, and then there's obviously Notes AI, which I'd like to also invite you to. But also, if you want to submit, this is the final week where you're able to. So please do submit for that. But I'll mention that at the end. So I think we can more or less dive in. While you're getting your screen set up, I'm having a quick look at chat. I see somebody from Brazil. I don't know your name, unfortunately, here in chat. I cannot see it. I hope that's okay. So welcome to you. I see Edwin from Sweden. I see Nicholas. Thank you for joining. And Nicholas from Austin, Texas. So welcome to you as well, watching live on YouTube. It's great to have you join, and everybody else, welcome again. Thank you for your loyalty, I guess. Thank you for watching these episodes every month. Thank you for your comments, your feedback. I've received another comment with a longer question just the other day, which Jesus and I we shared. We don't have the time, I think, to talk about this episode. I think because we have a different topic, but we definitely keep it in mind to look at that at a later point in time. So as always, it means a lot to us that you watch it, that you follow us, that you give us this positive feedback on all these episodes. So thank you very much for that. And if you have any questions, any feedback, any comments, the YouTube comment section is the best place to go for that. This is also the YouTube video description is also the place where you can find all the links and everything else we have covered today. This is the one that I'm updating. Next to obviously the repository on GitHub, which you also can check out a few days after today, where we then have all the things updated that we talked today. And Juan from Malaga is here, Aker from Belgium, Joe from Norway. So thank you all for joining. It's great to see you all. And while I'm here in giant mode, let me get this out of the way. So here we go. All right. Yeah, this is the screen. Everything is here. Let's kick it off.
Excellent. Yeah. So let me open, as always, with a few slides and provide the context and what explains the title of the session today. So let me click onto the next one. So what you see here is a post by Nicholas. And it's interesting because I've got to the opportunity to connect with him, not on this particular one, but even on a follow up that he wrote. And we, as we often do in technology, we disagreed on certain things, but we had I think a constructive conversation. And well, our kind of discussion started on some ideas around how to model data in an efficient way in property graphs, in RDF. I kind of decided to jump to this one because I thought it would be an interesting exercise to analyze. As you know, Alex, and because this is a topic that's very close to our hearts. I mean, if we counted the number of sessions that you and I have spent looking at ontologies and knowledge graph creation with property graphs, and so the first reaction, it got me really angry. I mean, you probably remember that because sometimes these kind of sometimes these type of analyses are presented in a way that I think it's not entirely objective and accurate. And so what I wanted to do today, with a little bit of humor, of course, is to analyze the Nicholas' work, because the great thing is he posted on LinkedIn, but he shared a repository, and yeah, there were some statements that I just plainly disagree with, and I want to challenge them. But this has given me the opportunity to take a kind of a constructive angle. So I've kind of written some code and kind of tried to rebate some of the things that he stated. And actually, I had the opportunity to let him know that we were going to be taking these, doing this analysis. So I don't know if he's going to be joining. He could, but yeah, I hope he will take it positively. We agreed that there was not going to be any feelings hurt. So this is entirely an intellectual conversation. But I want to be explicit about my point of view, our point of view, and some of the disagreements that we have in some specific points. So let's get started. But well, as you can read, and there's the link down there. Well, basically the exercise was, I mean, he was challenging the fact that, well, it's true, and I would agree with him, that sometimes building a knowledge graph without having an ontology driving it is probably not the best practice. But I think that some of the arguments that he used were not entirely accurate, and that's what we're going to challenge him today. So basically what he took is, okay, I'm going to create an ontology, and he uses the OWL formalism to create the ontology. Pretty much what we've done, in many sessions here, and feeds that ontology with some prompting to an LLM, and uses that to build a knowledge graph in the first place out of some unstructured data, some natural language text, and then after building the knowledge graph driven by this ontology, he implements some retrieval strategies. Today, we're going to be focusing on the knowledge graph construction, because I'm interested in what he describes as the Jaguar problem, right? So let's get started, and you have seen it on the screen there. So what he refers to as the Jaguar problem is basically the problem of ambiguity in natural language, right? So in his example, he kind of artificially combines, which is a great example, by the way, the use of the term jaguar, right? So jaguar can be, of course, an animal, but it can also be a car, as we know, as a car maker. And it's also, I didn't know, a type of a guitar, brand of guitar model, a Fender model, right? So the thing is, okay, there's a term used in many different ways. I need to disambiguate that. And LLMs on their own, they're not going to be able to do that. So we need to give them this sort of structured guidance in the form of an ontology. And well, I agree with that. That's not entirely accurate. Let's start with the first one. And so the first inaccuracy, I would say, is that this idea of LLMs cannot deal with lexical ambiguity without help. Actually, they can. They are great at that. That's the one thing they're amazing at. And as an exercise, and that might be a minor one. So I suppose Nicholas would agree with me on that. So one of the things that we can do is take this text and give it without any context at all to an LLM, and an LLM will be amazing at disambiguating and telling us there's three different interpretations of the notion jaguar, and one is a car, one is an animal, and one is a guitar. Because, well, that's the great thing about LLMs, right? So they've read the whole internet and a lot more. They've read all the text in the world, and they can make sense of this ambiguity. That's amazing. So true that ontologies are going to help us, but in this case, it is not accurate that without an ontology, an LLM would not be able to make sense of that. And I'm going to kind of sort of argue each one of those. And while this one, I suppose no one will disagree with me on that. Am I sharing my whole screen, or
Yes, yeah.
So let's go to, I mean, the post, like I say, it's on LinkedIn, and we have the repository. So what I'm going to do, quite simply, is go to the data, and well, the text is available there. So that's the text that combines the three interpretations, and I'm doing it manually. We're going to go into code in a moment. But what I'm going to do is I'm going to just literally feed it to ChatGPT, and I'm going to go with an old model, right? So let's go even with the legacy one, just to prove that this is not. Yes, models are getting more clever. Let's go with 4.0 maybe, which is, I think that's probably the.
Yeah, you're still sharing the
I'm not
text.
Sharing?
No,
that means that
maybe it's a.
Let me share my.
Let
me share my desktop instead.
Okay.
Let me know if you.
And Niklas, by the way, is watching. He says hi. And
oh, perfect. So yeah, I actually told him I would appreciate his feedback, and will prioritize his comments. I thought we might consider for the future kind of more of an interactive session, but for today, it kind of was as often in our case, kind of a last minute decision. But anyway, I'm going to feed the text as literally copy paste. We're going to take a more programmatic approach in a moment. But what I'm going to do is give the text to the LLM, and well, it's without even asking the question, and I selected 4.0, it would do some comments on it, but I can say, literally asking, what are the different interpretation of the term Jaguar in the text? Be concise, because otherwise it can get a bit verbose. And it's no surprise that it will tell you, hey, there's an animal, there's a car manufacturer, and so yes, LLMs are great at that now, and they don't need ontologies on that. So that maybe that was me being a bit picky, but the value of ontologies come after that. So is when we want this built-in knowledge of the world that's sub-symbolic, as we've discussed many times, that's based on a neural representation of the world. So if we want to extract bits of information and align it, with the shared vocabulary, which is what defines the ontology, right? And just to be
just to be maybe arguing in favor of what Niklas wanted to say is probably if you just give it without this additional context, if you just add the sentence, I was hit by a Jaguar, dear ChatGPT, what kind of Jaguar was it? It probably would not give me maybe the car, maybe the animal, and then maybe there's a 50-50 chance it would come up with either. And if you run it 10 times, you would get different kinds of.
But again, absolutely. So it will make exactly the interpretation that you and I would make. So it's an ambiguous expression, and it can mean a car accident. It can be a figurative reference. So exactly, it totally gets it, right? And it realizes that there's ambiguity. So yes, of course, I can say it. Well, in the context of wildlife, what can it mean? So if I it's not so much giving context. It's more like that's the interpretation of the term that I want to use. But okay, I agree. So that was a bit picky. But this is, the first one is the kind of a minor one, but something that that I wanted to make clear. Now, let's go to and that's my stamp of, hey, that's fake news. That's not entirely true. But anyway, that's the first statement. Let's move on, because that's what. And actually, if you go in the code, and this time for the first time, well, not for the first time, I've checked the code into GitHub in advance. So I even make a small fragment of code that shows how this has been a built-in capability in LLMs from the very beginning. And I even started with legacy models. So that's not entirely accurate, in the sense that LLMs can and will be able to disambiguate very, very precisely. Now, if we move on, the second problem is, okay, it's inaccurate to think that by feeding an ontology in the context window, which is exactly the way we operate and exactly the way Niklas has implemented that in his repository, will guarantee that the extracted entities will align with the schema. And that's as simple as well, LLMs are language models, right? And they will take that as a guidance, but by no means they will take that as a deterministic or a kind of a symbolic way of interpreting data. So what's happened, and here I'm not even going to show code, is that, well, he states that by using an ontology, we're guaranteed that it's going to generate RDF that aligns with the ontology. Well, it's not guaranteed, unfortunately, and that's exactly what happens, because ontologies are knowledge artifacts that are symbolic and that are unambiguous and have well-defined semantics when interpreted by an inferencing engine, by in this case, since it's an OWL ontology, by an OWL engine. But we cannot expect an LLM to make the same interpretation of it. And what's happened, and that's even in Nicholas' repository, if you go to the generated output, we see that first in the ontology, we define the property occurs in. So this is a fragment of the ontology that's in Nicholas' repository, where we define occurs in as an object property that connects an animal to a location and basically indicates the state where the animal has been observed, right? It is known to occur. But then in the extracted data, we extract an entity that's actually a jaguar population. It's not an animal, but a group of animals. And it states that it occurs in Sonora, which happens to be a state. So basically, it's using an ontology, it's using a predicate, a relationship, an object property in this case, in a way that's not aligned with the ontology. Of course, we can think of it, it's not super critical, but the important thing here, and we've experienced that in many of the experiments that we've run, Alex, is that we cannot, at least not this way, we cannot enforce the structure of the generated output. And the consequence of that is that, well, if you run reasoning, if we go back now to the RDF world, what happens if we state that this, I can't even try to pronounce, Wasaba Sauripa, whatever, this population, when we say that it occurs in Sonora, in the state of Sonora, what my triple store would infer, if we run some inferencing, is that that is an animal. It's not an animal, it's a population, but it will infer it's an animal because we said that the occurs in is a property whose domain is animal. So what are the consequences then in the validation queries that Nicholas has written? If we count the number of animals that have been extracted, we will get the wrong number, right? So anyway, this is kind of further analysis. The important thing is we cannot, this does not enforce that particular behavior in LLMs. Now, there is a way to do that to some extent, and we experimented with that in episode, you're going to have to remember, Alex, but you remember when, I think we call it blueprints for knowledge graph generation, and we tried exactly that. So we have an ontology and an OWL ontology, and we feed it to the LLM, we feed it some unstructured data, and it would generate, we tried first to generate triples, then we tried to generate some JSON, some random JSON, and then we tried a third example when it was, okay, let's not pass the ontology, but let's provide a pydantic definition of the model that the ontology describes. And then some LLMs happen to enable structured output. These days, most of them. And one thing you can do with structured output is precisely enforce. And in this case, yes, you are enforcing, right? So you're making explicit that you're only going to take explicit output in the form that's described by your pydantic model. Now, what's powerful is that pydantic can generate some JSON. These models can generate some JSON that's controlled by this pydantic definition. And then the JSON, if you want to have it as RDF, is one of the possible serializations of RDF. You can use JSON LD, and that's a way of, in this case, yes, enforcing it. But the fake news here, the inaccurate here element is that no, we cannot, unfortunately, expect that by providing an ontology, we're going to be sure and certain that the extracted triples are going to align with the ontology. And again, that's another misconception, not in this context, but in many others. People sometimes refer or think of ontologies as as models that are enforced in your data, as constraints. They're not that. Ontologies are descriptive. We talked about that many times, so we're not going to spend time today on that. But if you're building a data ingestion pipeline like this one, a knowledge graph construction pipeline, you will have to take care of that, because you will face situations where, as we've seen, well, as Nicholas has seen, because this is in his output data, we will have triples that will not be aligned with the ontology. That's the way it is. Good. So that's the second one. Now let's move on to the third one. And
there's a yeah, because there's just a tiny question from not Niklas but from Nicholas on YouTube, and he says, but doesn't the ontology give us rules to better check if the output is accurate in
Absolutely, but then that is post-processing. So yes, one thing you can do is, okay, I'm going to take the triples that have been produced by the LLM. I'm going to load them, if that's what he means. Let's load them in a triple store. Let's run some inferencing and let's detect inconsistencies. I mean, the ontology wouldn't help in that case, because this is a valid statement. That's the problem. I mean, as we saw in the previous slide, this is not wrong. I mean, this is a statement that's valid in an open world, which is the world where RDF exists and ontologies exist. So the consequence is, by stating that, what I'm going to do is I'm going to derive that this is an animal. Now, if we have some shackle constraints, I don't think Nicholas goes into that space, you could define things like that and say, well, occurs in can only happen between these. And then you look at it from I know it's a bit pedantic, but that's the way RDF works, right? So if you define a constraint like shackle, maybe to Nicholas, not Nicholas, but the other Nicholas question, you could eventually, yeah. But then that would mean, okay, I'm going to store or process my generated RDF. I'm going to run some validation rules, and then I'm going to determine if what has been extracted is valid according to the constraints that I've defined. But my point, and I reiterate that, is that don't expect that as an output for the LLM, because the LLM does not understand RDF, does not understand ontologies, or it understands it at a language model. That's another misconception that we're going to get to in a moment. But this expectation is not met, and it's not to be expected. Okay? Good. So the third point, right? So well, he states, and it aligns with the previous one. So there's no need for post-processing. Well, Nicholas has just given us an example where, yes, I mean, post-processing would be a way of validating the quality of the triples that have been extracted, and you know, that would be one way. But there's some additional ones. So what Nicholas states is that there's zero post-processing, because yeah, the knowledge capture in the ontology provided to the LLM is guaranteed that the output is going to be perfect, right? Well, it's not entirely true. And again, that's just a misconception. We're talking about a language model. It's not a deterministic reasoning engine based on OWL. If you run that, you know what things are derived and why they are derived, how rules are chained and how inferences are chained. In an LLM, we have absolutely no idea of what's going on in there.
True. Very true.
Examples of so there's an inconsistent use. Again, that's another expectation. In the prompt, Nicholas tells the LLM, take the ontology, do an analysis of the text, generate triples out of it, guided by the ontology, and make sure that every entity that you extract, every resource that you create, is annotated with the proper label. Well, the LLM decides to ignore it, as they do many times, because again, this is not a deterministic system. So in the output data, and again, I'm not running it, but I put a pointer here to the Jaguar's TTL, which is the kind of extracted version of the process that Nicholas has run. We see that the use of RDFS label is totally inconsistent. So in some cases, the labels are there, in some others they're not. Now this is not something that then we can infer or we can complete like in the previous case. Here, either you extract it from the text, or you probably will have to generate it out of the I don't know, the URI or something like that, or repass on the text and try to get it. So yeah, this is again a random decision by the LLM, where the LLM decides to ignore the instructions in the prompt, which is something that we have to be unfortunately prepared to see. So important thing here, the ontologies don't add you guardrails in that sense. In ontologies, as we're going to see, is just another way of provide guidance in the form of text. not very far from, anyway, we'll get there. But second one, there's duplicated triples. Again, duplicated triples is not a problem, but it's not efficient, right? It's generating the same triple multiple times, which, you know, ultimately, yeah, arguably, if you load it in the triple store, that's redundant, so no problem at all. But then there's also arguable and questionable interpretations of the ontology. So this is a fragment where there's a group of students, the students of this middle school, that, you know, the LLM has decided to label as a person. I mean, I think we can get into philosophical discussions, but this, to me, it's not an instance of a person. There's other persons in the data set that are less ambiguous, but again, this is the ambiguity, this is the randomness, this is the stochastic nature of LLMs. And it's not, again, it's important, it's not by providing a formal definition in the form of ontology that we're going to be safe from that. So yes, we're going to have to, unfortunately, post-process and check and validate and assess the quality of what has been produced. That's the sad truth. So sorry, Nicholas, that's again not entirely accurate. But now we're getting
made a comment in chat, and he says, I agree with Jesus on everything he says on the data extraction. Never expected this simple example to be dissected by an expert like Jesus.
Well, we're here to learn, right? So that's the
exactly, yeah.
But anyway,
like you said in the beginning, this is not to, you know,
and that's why, you know, I got, you know, angry, because, you know, I know that the intention is good. I hope, Nicholas, but but sometimes, you know, and well, we'll get to the conclusion at the end, because we saw that the post had, in our graph world, it had a significant impact, and I'm happy for that. But it's important to understand these nuances and know what we're doing, especially when we provide guidance to people who are, you know, less experts or are new to this space. Let's get into the fourth inaccuracy. So, and that's important. Again, it's the same thing we've said already a couple of times. Nicholas seems to suggest that the LLM is going to interpret the ontology as if it was a reasoning engine. You know, a reasoning engine, let's, you know, now move out of the LLM space, is a deterministic symbolic system that understands what's in the ontology, has built in the semantics of the OWL language, things like, you know, inverse functional, you know, transitive properties, axioms, and it knows exactly when we can derive new triples. And that's not ambiguous. That's simply rules. I mean, there's rules that describe the behavior on how an OWL definition can be interpreted, and these systems just run it. And then you get additional triples that are derived. And like I said before, every triple can be traced back to a chain of reasoning. Very explicit and like I say, non-ambiguous. There's no way LLMs are going to be able to implement that. So it's LLMs. And I don't remember if I'm going to go into that here. Yeah, so they, well, that's what I was said, yes. So we need a reasoning engine, and it's dangerous to expect that, because you're going to be surprised. I mean, in some cases, you're going to get derived triples, but in some others, well, if we cannot get the LLM to even align with the ontology, imagine complex chains of reasoning. So let's not assume that the LLM is going to get anywhere near that. So that's another very important clarification there. So sorry, that's not actually that reminded me. I didn't know that I had put that here. But well, not the last time, because I saw Aura at the Connected Data London, but we were at the Knowledge Graph conference back in New York in May, and we were in a similar situation. I was part of a panel, and we were talking about, I think in that case was detecting changes. I mean, it was about ontology change management and versioning, and we were talking about how to detect changes between two versions of an ontology. And someone came up with, we can throw it at an LLM and find it. And I said, what are we talking about? I mean, this is an entirely deterministic problem. So we're comparing two, you know, formally defined representations that we can compare and detect. And he found that interesting, and he quoted that. So in this case, we're exactly in a similar situation. So an ontology, and specifically ontology inferencing, is to be run in a deterministic system, not in an LLM. So there's not an expectation for that to understand the formal interpretation of OWL, right? right? So again, unfortunately, Nicholas, that's not to be expected. And the fourth one, I think I wanted to get to this one, because that's, in my opinion, the most interesting, and one that I've learned from as well. Because and I get back to this episode that we run. I don't know if you got the edition or the series.
Yeah, that was about more or less a season ago. Blueprints for Knowledge Graph Construction from Unstructured Data is what we called it. It was season 2, episode 3.
Exactly. So there we already kind of got an intuition that, yeah, we're passing an ontology and we are extracting triples, but does the LLM really understand the ontology? And I was, of course, passing an OWL ontology in turtle format, and I said, okay, I'm going to pass a text-based description of the ontology. And surprisingly, we got the impression that the quality did not degrade at all. So, but we didn't go any further. So I remember putting a question mark there and saying, but does it really matter if we put it in? Well, I took it to the next level here, because again, the assumption is that LLMs will perform better when we prompt them with the formal description of the domain as an OWL ontology than if we do the same thing with natural language. And I know that Nicholas gets into this trap of labels but not concepts. I mean, strings, but in a property graph. Well, let's put that to the test from an LLM point of view, because I can agree in some things, but let's see what happens when we do one thing and the other. So what I did in this case, exactly. So things, no strings, and all that. But it turns out that LLMs do love strings, and let me show what I mean by that. So now I'm going to share my Python code. Should I? How can I do it? Because this is not super exciting. Well, let me show you what I've done. Because actually, I'm going to go to the. I'm still sharing my desktop, right?
Yes. Yeah. We see about
So if we go to go in Meta, so what I've done is, because running it is the boring part. But if we go to the last, I think it's 40. Is that there already? So we might need to
I didn't update it yet. No.
Yeah, it's 41. Here we go. Anyway, so what I've done is, okay, so I'm going to take the ontology that Nicholas created, and I'm literally picking up from his repository. So let me show test ontology here. So what I do is, this is the pointer to Nicholas' repository. So I get the ontology, and I get the text, the raw text that we saw before, right? And what I'm doing here, and this code is for you to see in GitHub, is I'm going to run 2 tests, right? So I'm going to do exactly what Nicholas does, which is, hey, LLM, go take this ontology and extract triples, aligning with the ontology, etc., etc. And then I'm going to do exactly the same, but instead of passing the ontology as turtle, as OWL turtle, what I do is I apply a transformation that presents my ontology in natural language. I'm going to show what that looks like. And then I pass these strings. It's not URIs anymore. It's not formal definition. It's not turtle. It's just a string. It's a natural language description of my domain. And we're going to see how the LLM behaves. And the output, we're going to still produce it as RDF. And that's important, and Nicholas and everyone. The output format is entirely independent of this process. And I'm going to get to that in a moment as well. But what we're doing is we're passing the LLM some context on how it has to behave when it does the entity extraction. Right. The output format, whether it's triples, whether it's JSON, whether it's natural language, whether it's CSV, whatever, doesn't make a difference. It's not connected one to the other. Again, let's decouple things. We're not in a reasoning engine. We're not in a triple store. We are talking to a large language model, which reads language and produces language. It happens to be able to produce a specific syntax. But so what I'm doing here is, well, as you can see, you can go through the code. It's boring, but I'm going to run this example 10 times, n times. I mean, I can run it now. Because we're using, I follow Nicholas' example and use GPT-5. So each request takes roughly 3 minutes. So I can run it, but I've done it in advance, right? So and the thing is, I do the following. So I run the ontology prompt, and then I run the natural language prompt, and then I save the output as REF, right? So, and then what I do is, in order to compare the two, to compare the output, what I've done is I've created a collection of tests, right? Because, and again, this is important, and I want to emphasize on this, when we measure the quality, we have to quantify that. We have to create these metrics, these evals, right? So, and what I've done here is I've created a collection of tests, which is a collection of Sparkle queries, right? So I want to make sure that the extracted triples in one way and the other, well, first of all, contains all the Jaguars. There's 16 of them. I want to make sure that they're all extracted. And this is, you know, if we understand, and specifically with their names, right? So these Jaguars have names, and I check if all 16 are extracted. Then I check if for a given one, El Jefe, if we're collecting all the properties, like the date of birth, the date of last sighting. Anyway, I write very specific queries that I know they are in the natural language text to be able to, and we could go on, right? How many observations of the that I've written 12 of those. How many monitoring? How many? I mean, is it who named the Jaguar? Is this region detected? Is the region linked to the Jaguar because it was found in that region? Is the region properly connected to the country? Mariposa is another Jaguar that appears. Is the connection between the two of them because one is the mother of the other? So it's a really extensive collection of queries that will really quantify and assess the quality of the generated output, right? So my exercise is, and you can look at the code, not here. So first, the test onto will run the two requests to the LLM, one with the ontology and one with the natural language version, and it will persist the text, the output as triples. And then we have a second one that analyzes the results, right? So it will go iterate over each one of these outputs, and it will run every single one of the queries that I've just shown, right? You see, we have here the collection of queries. So I'm going to run them, and I'm going to say thumbs up if the query, if the test passes, or thumbs down if it doesn't, right? So fail or pass, right? So
makes sense.
I'm going to, I guess you're seeing that coming probably, but yeah, well, surprisingly or unsurprisingly, hang on, where is this 32? I don't know where I put my. Here we go. Can we see the code here?
Yeah, well, it's here.
I've like I said, because it takes roughly an hour. If we run it 10 times for each one of them, three minutes each time. So I have the output from the previous execution here. I can show. You can actually. I'm not going to show it because it's boring. I let you run it. But you see how it basically runs the tests one after the other, and it produces the files. In some cases, it crashes. That's probably retrieving data. Anyway, it produces a number of turtle files. And then on the turtle files, what I do is I run the analysis. And that's the interesting part. Let me...
Okay.
So I run the analysis. And what happens is that, well, we look at... so there's maybe a bit complicated to interpret here. But here are the 12 queries, right? You see them by name, the tests. And I say, well, the first GW or OWL are the OWL version ones. So these are the OWL 1, 2, 3, 4, 5, 6, 7, 8. So the ontology passed as OWL, and the one passed as natural language. And we see if we pass and we fail. So this is the, in order to put it in a more readable form, I put it in a chart, right? So this is, I haven't put this in GitHub, but again, this is something that you can run. The code is there, and you will get, of course, not consistent results, but roughly it will show a trend. So I've translated the pass and the fails in zeros and ones, and here's what the interesting results. So in general, not surprisingly, the natural language feeding of the ontology tends to perform better. So the red is the natural language, and the OWL is the blue one. So in most of the times, we see that we pass more tests. The red column is higher, than the blue column. There's exceptions, right? So it looks like there's one type of query here. But in general, and if we aggregate all together, 62% of the times, the natural language version gets the right extraction according to the ontology, and 53% of the time does the OWL one. So that's an important, because the conclusion, and of course this is ultimately a statistic, right? And an interesting output just to show you what this looks like. So the prompt, I saved the prompts here, and the OWL prompt is exactly the one that's I took Nicholas's one. So extract relevant entities, and make sure that the entities have the label, and use this namespace. I don't know if I've added some elements, but ultimately you pass the ontology, and I literally paste the ontology in the prompt as it comes from Nicholas' repository. So this is the version 1, the one that produces the first set of results. But then there's the other one, the natural language one. What I do exactly the same, but instead of passing an ontology, I'm passing strings. It's just a description. I'm passing the terms. And as we have seen, well, the LLM seems to be happier with that with a formal representation.
Yeah.
Okay.
Which is funny, because obviously coming from a background of using,
yeah, because the thing, I think it's important to remember here that what we're doing, and Alex, you know that we are big fans of using ontologies in this webcast, right? So we use it in practically every session. It's important to understand that an ontology is a formal, machine-readable description of a domain, and we can do what that means is that we can parse it, we can read it, and we can programmatically do things with it. And here we've done all sorts of things. We've run inferences on Neo4j, we've done validations, we've done data ingestion pipelines on the fly driven by the ontologies, all sorts of things. That's the whole point. I mean, the ontology drives behaviors, and you can do it programmatically. You can, and deterministically, because I can parse an ontology. I know what's in the ontology and how it should be interpreted, and I know how to use it. Now, when we go into large language model territory, this thing loses all its meaning, in the sense that it becomes just text, and that's important. So yes, it's providing guidance, and the LLM can sort of make sense, because it probably has read all the OWL ontologies existing in the internet, in GitHub, and everywhere. But it's no more valuable than a text description of the same domain. I think that's an insightful thing. And again, running these 10 times, I mean, I think it's a robust test, because I came up with 12 reasonably complex queries, and I compare the two approaches. I mean, I've run this a few times, and the results are consistent. They might vary a little bit, but that's to be expected, because of the the stochastic nature of LLMs. But that's important. I mean, this is another inaccuracy and another often misconception, right, from when people using ontologies, because yes, LLMs work on language. They're not inferencing engines. So I think that's an important element to keep in mind. That said, I mean, I'm not saying, of course, don't use ontologies. And like I said, we've used them many times. But
we use them.
If we want to enforce and be more strict about the output of an LLM, the tool to do that is structured outputs, and typically pydantic definitions. Now, the great thing is that an ontology is a formal description of my domain. So I can parse it, and like we've done many times, I can translate it into a pydantic definition. So the ontology will have a new incarnation. I mean, yes, my master ontology is stored as an OWL, but I can now transpile it into a pydantic definition. That's going to help me have the LLM behave in a much more predictive way, right? And remember, I don't know which was the episode where we had this kind of circle, where we had the ontology we created as a W3C standard, but then we materialize it as a model for the data ingestion tool in Neo4j. Then we use it as a structured data ingestion tool in Aura. So that's the great thing about ontologies. They're formal descriptions that we can action on, and we can transpile, translate, convert into something that we can use for our own benefit. And in this case, I guess the lesson to be learned here is that the moment you jump the line of the LLM, we're in text and language territory, So ontologies have a value. I mean, still have a value, but we cannot expect them to be the kind of the type of artifact and the type of deterministic element that we have on when we use them, for inferencing. So good. That was another inaccuracy that I wanted to call out because I think it's important. And then, in addition to all that, and that's not exclusive of Nicholas' exercise, but this approach is not free from hallucinations. Again, the moment we go into LLM territory, the chances of getting an hallucination, it's still there. I mean, it's not because we provide an ontology that we're going to have any additional guardrail. That's something that, again, post-processing could eventually detect it. But what's telling me is that there's a property that's called is dependent on, that Nicholas defines in his ontology between two communities of Jaguars, and is dependent on means that there's kind of some movement of Jaguars between one community and the other. So there's no such statement in the text, and you can go verify that. But an additional validation is that there's, I believe, 7,000 miles between these two locations, which is basically technically impossible for a Jaguar. I think I was reading they can move between 30 and 200 kilometers, in terms of I don't know what the right term was, but this kind of movement between regions where they kind of so this is not only not viable, but it's also not present in the text, right? So it's not that it's incorrect, it's that it's completely generated. So it's a hallucination. Again, what is rigorous and strict in one world becomes pure text guidance. So that's important to understand. So we're not free from hallucinations. So assuming that the guarantees that we get from symbolic reasoning on one side are not preserved the moment we move on the And just to conclude, because I'm conscious of time, I mean, the last one, Nicholas, I didn't like that. I mean, you cannot do that with LPG. What does that even mean? I mean, have we even talked about data storage? I mean, have we even talked about triple stores? I mean, this was a conversation between our agent and an LLM, and how we prompted, what does it mean you cannot do it with LPGs? We have done it. I mean, the output of the LLM, even if it's guided by an ontology, I can produce output in whichever form, even if it's RDF. I can import RDF in the property graph. There's no connection at all between the storage, and that's, I'm bored of talking, we keep crossing lines as, what does it have to do? An ontology is a knowledge construct, is a knowledge artifact that makes no absolute assumption whatsoever about how do you store, how you preserve your data, how you persist your data. So what do you mean exactly by that? And I know what you mean, but it's, it's absolutely pointless. I mean, and if you're interested, go have a look at the next to 30 episodes where we have successfully and in all shapes or forms combine formal descriptions using ontologies in OWL, in RDFS, in SCOS, in many formalisms, and ultimately we persist the data in Neo4j because that's what ontologies are for. I mean, there's no prescription in terms of, because I'm using ontology. Yes, if you want to run inferencing in the form of OWL inferences, good luck, go do that. And you need a triple store, and you probably need an inferencing engine. But that's not the only way of using ontologies. There's so much value in them. And again, this is the subject of many previous episodes. But this was my rant, Alex. So that's that I wanted to touch on the inaccuracies. And I'm conscious that I've only focused on the knowledge graph construction, but yes, you can use ontologies. Yes, you should use ontologies. Of course, you should use ontologies. Now, ontologies can take many different shapes, can be used in many different ways. One possible way is inferencing, and that will be typically more associated with triple stores. But of course, you can use them with property graphs. Of course, you can. I mean, this is just data management best practices. It's absurd to kind of put these two things in contradiction. So that's the takeaways. I think I've repeated myself is like, of course, use ontologies, understand this boundary. I mean, where you are the moment you move into LLM territory, everything is text. So if you want to enforce guardrails, checks, controls, you're going to have to do it differently, and that can be, again, driven by the ontology, and you have plenty of examples in our webcast We've touched every single approach. And yes, you can persist that in Neo4j. And yes, you can get the best out of ontologies in OWL, in any formalism that you want, in property graphs. It's absolutely independent. That's it. That's me, Alex. I hope that was useful. And the code, like I said, it's available for everyone to go and test. And yeah, well, I have to thank Nicholas in a way, because he got me to experiment with some of these things to try and prove him wrong in some cases with facts and with code that I hope he has a chance to go have a look at. But I hope this conversation, this intellectual exchange will go on, and I hope that we make an effort, because that's where my rant came from. I mean, there were factually inaccurate statements in that post, and some people, where I wonder, maybe they thought that that's directionally in my interest, but have you really read what's in there? And that frustrated me, and I wanted to clarify that, and I thought this was an opportunity to do it, and I hope it was useful. There you go.
No, it was very interesting. I want to give the Niklas in chat the opportunity here to speak out a little bit, or speak up a little bit, and he wrote a little bit earlier. I appreciate the work that Jesus have put into this and showing the weaknesses in my method. To be honest, what I was trying to do with my original post, I wanted to show what you could do using RDF, OWL, and LLMs to gain some interest for knowledge graphs. If I had known the impact it would have, I would have put much more work in the example, and I would have been a lot more nuanced in my statements.
No. I mean, and don't get me wrong. I mean, we have we do that every week, every 4 weeks when we do these webcasts. I mean, of course, RDF is there. I mean, what I think things get wrong, and it's misleading, I have to say, is when you try to put in opposition that with the property graph. The property graph is a way of storing, managing your data that's perfectly compatible with RDF and with ontologies. Actually, we recommend. I mean, there's so many of our customers using ontologies and implementing this kind of approach.
Yeah,
when we kind of put them in contradiction, I think we're misleading, and I don't know if it's because lack of awareness, it's because it's lack of rigor, but it's important that these things are known. And but again, I think we're not suspicious from not wanting to experiment and try with these things. And this is not over, Nicholas. I'm going to also unpick your other model post on modeling relationships on properties, and again. No, sorry, I'm joking, but I might put some comments, because I think it's important to have this conversation and understand and articulate things in an objective ways.
Yeah, absolutely, and I think honest discussion is always great, and we like you said in the beginning, we don't want to treat this. I hope you understand, Niklas, that this is
of course. I hope
all in good mood, and has nothing to do with you personally, particularly. There were a couple of other comments here. There were interesting thoughts, which I'd like to give a quick look at. So Nicholas says you can't really treat LLMs like a computer. The input is always interpreted regardless of what format the input is. It's always going to be like that. And yeah, it's a good thought to keep in mind, because you always. Well, speaking of myself here, you tend to go into this motion. Okay, this is I get something that looks like code back. I put something in that is code, and the engine understands it. So I guess it must do some internal calculations or analysis or something. But what it is in the end, it is not that. It's not doing that in a way that we kind of expect, because the answers oftentimes are in such a good way coming back that we think, okay, then it must have done that, but we assume more than what actually happens.
I think the key here is understanding clearly what we're doing and what are we dealing with, and what's the power of ontologies, what the many ways in which they can be used, and the power of LLMs, which are amazingly powerful, but sometimes we get confused in terms of what to expect from the combination of the two, and these sort of exercises, I hope, help clarifying that.
Yeah, I think that's great, and I think this is also a good way of looking at this from these kinds of exercises, to actually always think, okay, what is really being done? What can I analyze? Or like your 10 test runs, is the output really giving me the answers I was looking for? Or was it a one-off lucky punch kind of situation? You never know, and so you always have to reevaluate a couple of times before going forward with that. So I think it's great. Another good comment from Nicholas on this AI: treat AI as an enthusiastic intern, productive but double check their work. So yeah,
That works.
probably also a good analysis. And then what did I see before here from Domenico? Domenico said when we had this natural language versus the OWL statement, is I'm surprised that natural language works better. It is what LLMs are mainly trained on. Okay, that's obviously true. Yes, you have much more context, much more words, documents that have been trained that comes from natural language and from RDF, from graphs, from any other programming language or query language. So I think, yeah, that's probably also something to keep in mind. Yeah, cool. Niklas says no hard feelings, so thank you. Good. So eventually we'll return the favor here. Thank you for this opportunity, I guess, to dissect your post and for you being open to it. And I hope, yeah, everybody, it was interesting for you. It was something that is how do you say, nurtured your thought process, and maybe gave you a couple of ideas of how to treat that and how to look with that, or how to work with that in the future. So I think that could be interesting. Before I let you all go, what I wanted to say, or Jesus, I don't know, do you have any final words here from your side?
No, not really. I mean, I was literally texting Nicholas and saying that I try to approach it with as objectively as possible, and there was an intellectually very interesting exercise, and I hope that was useful. So no, I think I think these kind of exchanges are really good and positive, and I hope that's the way it's received.
Yeah, like I think Rick is also in chat here. So keep posting your ideas, Nick. Definitely, this is not supposed to be we don't want to disencourage you. I mean, everybody.
No, quite the opposite.
All kinds of comments. Tag us if you write something. If you have a unpopular opinion, maybe.
We'll be reading and scrutinizing. We'll be reading every single line of code and making sure that we really care about this space, and we really care about practitioners, and we really want to provide the right guidance. So yeah, by all means, keep contributing, you and everyone. But yeah, we'll be watching you.
We'll be watching, definitely. So speaking of watching, we have a couple of more things happening before the end of the year. Next stream is on the 15th of December, where our colleague Irina and I will look at AuraDB, in particular the graphrag agents that have recently been added to AuraDB. So that's going to be a fun episode happening on the 15th. And on Wednesday, same week, on the 17th, Henry and I will look at the stranger graphs. I don't know if you've seen this. We dissected, or we imported Reddit predictions from the Stranger Graphs or Stranger Things fan base to predict what's going to happen in season 5, which is currently on Netflix. So we look at that, how you can make predictions through graph intelligence on a season 5 of Stranger Things. So should be fun and interesting. And like I said in the beginning, Nodes AI is going to happen on the 15th of April next year. You have until the 12th of April. So what is that? This is Friday, right? Yeah, this is this Friday. So you have a couple more days to submit the talk. We'd love to hear from you if you have anything to say. Maybe Nick, maybe that's something for you. Give it a thought. You have a couple more days, and anybody else obviously invited to present, but also invited to join us in April for interesting specific AI session on graphs and everything with AI and all the things in between. And yeah, I think with that, at the top of the hour, at the end of today's Going Meta, end of Going Meta for 2025. Again, thank you very much for being a fan, being a follower, as always, let us know how you like this episode, how you like the series in general. If you have any thoughts, any comments, please, YouTube comment section is the way to go, and also YouTube description is where you will find all the links. So that's it for me. Jesus, again, It was a pleasure. Thank you for joining today. Thank you for dissecting and for your work into the code and into the example today. And as always, it's fun and it was a nice episode.
See you all in the new year. So
yeah. See you soon. Take care, everybody.